Good morning, or good evening, good afternoon. My name is Wang. I'm a senior manager of DevOps with JB Hunt. I'm really excited about sharing my experience of applying some lean manufacturing concepts and process procedures to CICD pipeline. This a couple of years ago, it was in the early summer day in Michigan. I took a walk outside to enjoy the sunshine during my lunch break. And I saw this blue portable toilet on the top of a roof. Naturally, that raised my curiosity, so I started a little investigation. I saw a big lift truck in the parking lot with a lot of materials in plastic wraps sitting in the back. There is a big brown dumpster. Behind that, there is a small trailer office. A construction contractor was preparing for a roof replacement project. Looking a little closer, I saw a ladder against the building leading up to the portable toilet. Obviously, that's for the workers who are working on the top of the roof. So when the natural calls, they don't have to waste the time climbing the ladder down and go back up. I also saw two dumpsters in front of me. And the one that closer to the building has a wooden chute directly above it. And you can imagine that the workers would put the old roof materials in wheelbarrows, then carry to the wood chute, dump into the chute. The material would directly flow into the dumpster. Once the dumpster is filled up, the second dumpsters would be moved in place, so the work does not have to stop. But look closer to inside the wooden chute. You will see there is a plastic liner with vertical grooves, and that is for preventing material from stuck inside. As you can tell, this is a very simple but a very, very efficient setup for the job to go very steady and smoothly. And from this, we can learn a lot about software delivery. A little bit about my background. Like what I said, I'm a senior manager of DevOps with JB Hunt Transport in the beautiful Northwest Arkansas. I have only been with JB Hunt for about 1 year. And prior to that, I was application development manager in charge of CICD transformation. In the last few years, I have developed a passion for helping developers deliver software faster with better quality and also do it in a way that's easy on people. Doesn't matter what tools I'm using, Agile or Lean CI/CD or DevOps. And interestingly, before I got into IT, I have a background in engineering and construction. Maybe that's why I always pay attention to construction. When I'm not working, I do yoga, meditation, and running outside. I'm also certified yoga teacher, so sometimes I teach yoga for fun at work. And I mention yoga because later it became obvious yoga also has a lot to do with the software delivery and the workflow. Back in early 2015, I moved from operations to development. Prior to that, I was the IT operations manager in one of the most challenging operations in Ford Motor Company. The plant make high volume, high value product. That's the F-150 trucks. We worked 24/7. And of course, I was on call by 24/7. The work was very stressful. So when I got the opportunity to move from operations to development, I was telling myself, wow, nice. My life is going to be like very good, very easy. And it probably going to be like a semi-retirement. Of course, within a few months, I realized it's not true. Dev can be very difficult. Back then, we were using the traditional waterfall method for development with a lot of handoffs and a lot of defects with many UAT cycles. We cannot release the software very frequently. So on average, we could only release every 9 to 6 months. But it took us about 8 weeks to set up the lab for testing. And the release event was a 3 days, 3 nights nonstop event. And you can imagine that we will all keep ourselves up running, sustained by coffee, junk food, things like that. And that's not even the worst. Once we release our software into production, it's often like this little robot on the floor. It's rarely worked. Then we would spend the next 6 to 8 weeks to mop things up. So I thought to myself, there got to be a better way of delivering software. So I started to study how the most advanced, the progressive companies deliver their software. And in the process, I discovered CICD DevOps. And I was fortunate in the middle of 2017, I was given the green light to set up a new group called CICD Engineering to automate our software build and deployment process. And fast forward 10 months to May 2018, and we were able to release the software more frequently. It took less than 1 week to set up. And release, we cut down from 3 days, 3 nights to about less than 10 hours. If the speed is good, our quality was even better. And let me zoom in a couple of quality metrics as shown on this chart. On this chart, the blue bars are the total number of failures for each big release. And the orange bars are the failures due to package environment and deployment issues. You can call those deployment failures. And the first 4 events, releases, were using the traditional waterfall method, and the last 2 you saw in the red oval were using CICD. As you can tell, by automating our software release process using CICD, we were able to cut our defects down by 90%. Before I share with you how we did that, I'd like to share with you a couple of lean manufacturing concepts so we can all get on the same page. Let's start with one very basic concept called, let's look at what is work. You know, when we think about work, we usually think about, okay, I come to my office working 8-hour days and 40 hours a week, that would be work. But that's not how we define work in lean manufacturing. Many of you probably are familiar with this person. His name is Taiichi Ono, and he's called the father of Toyota production system. And he developed the Toyota production system in the 1950s to 60s, and that was later known as the lean manufacturing. One concept here is value for customer in lean manufacturing. According to Mr. Ono, work in a for-profit enterprise is a collective of activities that is create value for its customers. The key word here is value for its customers. Does that remind us something in Agile? Actually, the number one principle in Agile of the 12 is our highest priority is to satisfy the customer through early and continuous delivery of valuable software. What is continuous? That means flow. Once we have a definition of the work, let's examine our daily activities. And using this perspective, we can identify work, what is waste, what is non-value add, and what is the true value add activities in our work. Doesn't matter we do a roof replacement project and we ship load for our customers like in JB Hunt or delivery software. According to Mr. Taichi Ono, any activities would consist those three parts: waste, non-value add, and value add. And the customer only pay the value add. They would not care about the non-value add portion. Of course, they should not pay for the waste. Another core concept from lean manufacturing is workflow. According to Taichi Ono, workflow means that value is added to the product to each process while the product flows along. Again, here is the value add portion. When the work flows, you add value to your items, so you create value to your customers. And in developing Toyota production system, Mr. Taichi Ono also gave a lot of credit to Ford Motor Company for developing the original flow method in mass production. In my 18 years of living in Michigan, I learned to appreciate how much Mr. Henry Ford had impacted the world of transportation and, in fact, people's daily life. I think we can see that Ford became a dominant automaker in the 19th century by developing the most efficient workflow. And here is the fun fact. At least I didn't know in the beginning. When I read Mr. Henry Ford's biography, and one fact really jumped out. It stated that by 1926, Ford Motor Company had improved the lead time from mining iron ore to have a car completed with 5,000 parts on a train ready to be delivered to 81 hours. Folks, that's less than 3.5 days. So talk about how work flows. In fact, to some degree, this flow method is still used today. If you have a chance to visit Ford Rouge manufacturing complex, if you visit Dearborn, Michigan, you probably can observe how the manufacturers from copper coil steel stamp into stamped parts, shipped into body shop, then weld them together, then shipped the body part, the body into paint shop, painted over, then delivered to the final assembly for assembly. And of course, separately, you have to have ship engine, transmission, and thousands of supplier parts. And when you put everything together on a 7-mile moving assembly line, you have a final product ready to be delivered to your customer. So, of course, nowadays we use a lot of newer equipment, a lot of automation, but still the flow method is really still the same. But it was really Toyota who improved the flow method to the point it resembles something you could call agile. It was the lean manufacturing movement I talked earlier. A little history about lean. It actually started with an American, and his name is Edward Deming. And many of us probably heard about a timing cycle, which is called Plan, Do, See, Check, Act. It's also called a PDCA. And he was a professor, and he was promoting quality in every step of the manufacturing process. Of course, back then, US was booming. Nobody was listening to him. And so he went to Japan. Toyota tried to compete, tried to make a name for himself and compete with the big auto three companies. So they were listening to Edwards Deming and developed his idea into something they called a Toyota production system. And later that became a lean. So as you can see, the, 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 the later what we call the agile process is really a series of little timing cycles, iterative process. And this the core concept of this iterative process is actually CI. And of course, the CICD nowadays stands for continuous integration, continuous delivery. But back then, CI really stands for continuous improvement. And combine Agile with DevOps, that's when you would have a powerful tool for digital transformation. Using this framework, let's take a quick look of software delivery process. And on this chart, I was showing you a very generic flow of software delivery. So basically, in the beginning, business has ideas, and they want IT to develop into software. And you have the, of course, you have the test, making sure it's working. When it's ready, it's really a matter of business decision whether you want to put into production or not. And for any business to compete in this environment, we want to go faster. We want to have a better quality, and we also want to do it in a easy, want to do it in a way that's easy on people, not like driving people working harder day and nights without sleeping, things like that. So what's the answer to achieve that? The answer is a better flow, steady and smooth flow. In fact, life is better when things flow, not just in software delivery. If you look at an airplane, right, we travel by plane, the whole plane is lifted up and propelled forward by airflow, right? If airflow stops, well, I guess we don't even want to think about it. It's not going to be pretty. We also use pipelines to carry any fluid, oil, natural gas, and other kind of fluids nowadays. If no things don't flow in pipeline, life is pretty miserable. When things do not naturally flow, what do you do? Like car manufacturing, you put your items on a moving assembling line, and you force your items to flow and deliver work to the people. So if of course, just like in any kind of other flow, if the assembly line flow stops, the work stops, and you are not making money, your product. Even like a daily life, when we take shower, we want the water to be smooth, steady. And if you have big gases interspersed with drizzling, you want to feel very comfortable after you take in the shower, right? I mentioned yoga before, and one of the most popular yoga style around the world is called a vinyasa flow. When you combine your breathing with very fluid movement, and you get achieved the kind of equanimity in the end. You not just feel very good physically, you also feel very nice mentally. Of course, on our daily commute, if our traffic flows well, we get to our destination quicker and safer. If not, things we got stressed out. And a more recent example is when our supply chain does not flow well, you got these empty shelves in grocery stores, like what we are experiencing around the world now. How to achieve a better flow? Based on my experience, I want to share 4 points with you. Number 1, don't do things that you don't have to do. That's about eliminate waste. Number 2, minimize and streamline the non-value add activities. For a lot of things we have to do for our daily work, for example, if you are like working at JB Hunt, you are shipping a load, but the moving the load portion is value add. But we also have to do a lot of other things, like fill out paperwork, and we have to be complying with regulation, like allow the driver to take enough rest in between, things like that, and many things of that nature. And so they are not necessary, but non-value add. What you need to do is to minimize. You have to minimize those activities and streamline them. So number 3, very important, you cannot let defects move downstream. You need to fix defects at every station, which is really one of the central concepts of lean manufacturing. We call it 0-100. 0 stands for 0 defects. 100 means we strive for 100% FTT, first time through. First time through means everything you work is just work. No defects, right? And finally, once you've done 1, 2, 3, you want to automate everything you can to improve throughput and quality. So that's really make the software delivery process work smoothly as well. Of course, there are many tools and processes to eliminate waste and improve flow, and also fix defects in lean manufacturing. One of the most popular tools is Kanban board. And what I'm showing here is a physical Kanban board used in a factory. And here's a close look of the Kanban cards. Of course, later on, software development also adopted this method. And on the left-hand side of this chart, you see a virtual Kanban board. And on the right-hand side, you have the paper Kanban board. It's my view that if you first start with the Kanban, you want to go with the paper method, because the physical Kanban board really help you to visualize where your work is getting backed up. Where you have too many working in process, we call it WIP. Next question, okay. How can we prevent defects from moving downstream? Because things will happen, right? Things will broken. Again, in the lean manufacturing system, we have this little tool. And at the left-hand side, you see a little loop, and that's called an end-on cord. And later on, it became this light stack with push buttons, and finally, it evolved into something like the overhanging board. We call it we commonly call it process dashboard in factory. And in the agile project, in a lot of agile teams, they use what we call a radiator for the build status. But I don't want anybody to underestimate the power of this little loop. And it is powerful not because of the tool itself, it's because what we often say is the mentality. The revolutionary behind this end-on cord is any line worker working in factory can pull the end-on cord and stop the line at any time to get help if he or she thinks something's wrong. So I want everybody to pause and think this for a moment, right? If I'm an hourly worker on working on a assembling line, I'm making maybe 16, 18 dollars an hour. And if I think something is wrong, I can pull the cord, stop the assembling line. That's a lot of responsibility, right? That's a lot of revenue loss. And so this really demonstrates the empowerment in lean manufacturing. You're really giving the frontline workers the power to make the decision. This is also why, if in true agile implementation, you want to empower the team, they can stop the defects from moving downstream. And like what I mentioned before, of course, in software delivery, we would develop this virtual Kanban board, the end-on code sort of concept to stop defects from moving downstream. And let's look at a very generic CICD pipeline and see how it actually implementing those lean manufacturing concepts. Now you have this developer, and he or she working on his or her workstation and code test. When he or she feels good enough, she made a pull request. The code is merged into master and triggered a build by the CI server. And in the build process, you may want to run some unit tests, the static code check, things like that. If it failed, you would stop there and send feedback to the developer. The developer fix that defects, fix that bug, and then this whole process is being moving again. And each time it may advance a little further. And in the end, once things are working fine in the final UAT stage, the customer set is ready to go, right? It's use the same automation, same mechanism. It became a matter of just push a button, you release into production. So really, the whole design, the whole concept of the CI/CD pipeline is about enable flow and stop defects. Like what I said, in real life, things happen and you will have issues. Then what do you do when things are broken? Again, in manufacturing, lean manufacturing, we have a very powerful tool. It's very simple, again, developed by Taichi Ono, called 5 Whys. And the concept is very simple. When things goes wrong, you just ask why 5 times. And let me give you an example from the book Lean Software Development by Mary Papendike. Okay, so the first is something goes wrong, right? Why did we have missed this defect? The answer can be, okay, we didn't know the balance could be negative overnight. Then you ask, second why we did not know? Well, because Mary knows and she isn't part of the team. Then you ask another why. Why isn't she part of the team? Or the answer is because she's still supporting the old system and no one else knows how. Then you ask the fourth question. Why doesn't anyone else know how? The answer is because it isn't a management priority to teach anyone. Then you ask the fifth question, why isn't it a management priority? Answer, because they didn't know that a 20,000 investment could have saved us 500,000. As you can see, as you keeping asking those whys, the questions, right? And your answer, eventually the answer you are getting can be very different from the very beginning. This is a very simple and powerful tool. But again, if you are on the receiving end of this questioning, and it can be very annoying. And if you don't believe me, you can try at home with your partner and kids, and I can guarantee you are annoying people very quickly. But again, very powerful, simple, and it's very useful in all kinds of root cause analysis situations. Now, let me share how we apply those concepts in our CI/CD pipeline to reduce the defects. Our implementation of the CI/CD pipeline in my organization, and we had about over 300 manual jobs. We first scrapped them into 52 automated jobs. And for the bigger release, we also further consolidate those 52 jobs into 18 what we call push button jobs. As you can see from this screen on the left-hand side, that's in Jenkins. And with those push button 18 consolidated jobs, we can easily have one admin deploy the entire software package. Used to take 2,000 people in the old way. In fact, if our pipeline all works smoothly without any issue, we could just have one push button and you just push that one button, things will go. Our first, like what I said in the beginning, our first successful large release was in May 2018 using CI/CD pipelines. But our first time through for each pipeline was typically fairly low in the range of 25 to 30%. So I asked my team to focus on reducing the defects and improve FTT. And we're actually using a very simple process. Here, what you see is just a little table. It has the pipelines, description of the pipelines, any issues we encountered during the installation release, either in a lower environment or upper environment. And then we would captured what are the things we did during the process to keep things going. We called that ICA, interim corrective action. But we do not stop there. We also strive for a permanent corrective action, so the same mistake would not repeat. And we assign an owner to each of the PCAs, so we would follow things through. As you can see, here, in the beginning, we have in May 2018, we still had a lot of pipelines in the 20 or 30 range with FT. Only took us about 5 to 6 weeks going through this process. Of course, we did about 6 or 7 installations in a low environment just to improve the process. And by August 2018, we were able to improve our whole overall FTT to about 80%. And we still have some pipelines take 2 times to be successful, but overall we improved significantly, as you can see from this little table. I mentioned this chart before. Our qualities improved significantly once we switched to the CI/CD build and release, and we cut down the number of defects significantly. One thing I like to emphasize is there is a psychology factor at work too. Because with CI/CD, we were able to promise to the customers, look, we can release in any frequency you like, right? It's no longer necessary for the customers and the developer teams to push those half-finished features into production, because when you had the batch release, you can only release every 6 to 9 months. Everybody has the incentive to push anything into this release vehicle. Otherwise, you have to wait for another 6 and 9 months. But with the CICD, once that psychology factor is removed, people are more acceptive to not to push defects into production. So that's probably also contribute to the reduction in defects. And when you don't have defects, what do? You focus on uh, new features, because after each release, you have very little mapping up you have to do. So that's is really, really powerful thing. In summary, by implementing better workflow using Agile and CICD, we completely transformed how our organization delivers software. And like I said, it's much faster. We can release more frequent, and our the deployment, the quality is much better going to production, the software. And also it's easy on the people. People no longer have to work day and nights during release events, and that with much less defects, it also help us to learn to the different organizations to really work together. You can have that kind of a team feeling, the true team feeling, versus just the kind of, in the past when we talk about teamwork is probably more of a lip service. And this is a very, very important enabler of team to adopt Agile. Why we want flow and how to make things flow. So let me just recoup what we have talked about, and in order to achieve better flow. Number one, do not do things that you don't have to do. Let's reduce waste. Number two, minimize and streamline non-value add activities. Number three, do not let your defects move in downstream. Like what I mentioned before, with the CICD pipeline, it has a built-in mechanism to preventing defects from moving downstream, unless you want intentional and manual override. Excuse me. But in a full automated CI/CD pipeline, you simply cannot do that. And finally, you want to automate everything you can to improve your throughput and quality. I also advise you to do it in this order. You don't want to automate before you have minimized and streamlined your non-value-added activities yet, or you don't want to automate when you still have a lot of steps. That's just pure waste in your process. So let me just finally, I want to end this some fun facts with you. We all heard about the fable, the turtle and the rabbit was getting a race, and the turtle was slow but steady, and the rabbit was kind of very fast but very jumpy, a lot of stop and go. And in the end, the turtle actually win the race. But to me, the more interesting part of this story is not about the turtle win, and the slower turtle actually win over the faster rabbit. It's actually how many times they breathe, and heartbeat and lifespan, things like that. So if we look at a big turtle, and they usually take about they only breathe about 4 times per minute. And when you chew a turtle, actually they only breathe about once per minute. And that's all, again, versus a rabbit usually breathes 30 to 60 per minute. And look at a heartbeat. A turtle usually has a heartbeat of 25 per minute, 25 times per minute. And again, when you chew the turtle, they can slow down to about 1 heartbeat per minute. And a typical rabbit would have a heartbeat anywhere between 120 and 150s. Then look at how long a turtle can live. So a turtle usually have a 30 to 40 years span. For some large sea turtles, they can live to up to 80 hours. 80 years. And a typical rabbit only lives 1 or 2 years. So very similar to when we deliver software using Agile or CICD versus the traditional waterfall with big batch release. The big batch release, we work very hard, a lot of stop and go, but things do not flow. In Agile, many people mistakenly thinking speed is number one, but you don't really want to focus on speed first. Instead, you want to focus on quality. Once your quality is good, things are flowing, your speed will be up. So your Agile and plus CICD will not be as slow as Turtle. Actually, it's going to be as fast as Rabbit, but steady and a smooth flow. So I hope I have convinced you that the smooth, steady flow is better in software delivery and also in our life. Thank you, and we can have some questions if you have any.